Hi everyone, I'm Rosemary from GenScript, and today we're interviewing iGEM team, iGEM Madrid. So iGEM Madrid, can you please tell us more about your team and your projects for the iGEM 2021 competition?
Sure. Thank you, Joshmary, for that nice introduction. And well, here we are Jorge and Alba. We are members from the iGEM Madrid UCM team, based in the Complutense University of Madrid. I'm Jorge, the team coordinator, and I have studied my bachelor's in chemical engineering. Currently, it could be like my last year in iGEM as a normal member, let's say, or team coordinator, and I'm course in a master's in biotechnology. And well, that's basically all the academic stuff and things about me. I'm right now the team leader of Madrid CCA team. Alba, would you like to introduce yourself?
I'm Alba, and actually I'm studying the Bachelor of Biology in the University of Complutense of Madrid. And right now in this project, I'm part of the biotech team, and I'm doing especially tolerance and secretion. So yeah, that's my part of the project, and that's me and studying stuff. So I'm in the here we study 4 years of the bachelor, and I'm in the third one. So that's all.
Yeah, that's true. And about the well.
Oh, Alvaro.
Okay, so my name is Alvaro. I'm the co-coordinator with Jorge, and I'm currently working at the National Biotechnology Center from Spain. I did my biology degree here at the Autonomous University and also a biotech master. And now I'm working and I am the team structure. So we are currently working on the project, on the in silico part, and also trying to organize everything as well as possible. So in order to start working as soon as we get in there.
Yeah. Also, in representation of the rest of the team, I have to say that we are currently 9 members, so we are kind of a small iGEM team. Most of them would like to have been present here, but they couldn't because classes, lectures, and so on. So we are trying to represent all of our mates, but we are 9 people in the team. And probably we have like a very different profiles because it's iGEM, so you need a lot of different talents and skills. So all the people here are bio-based people, let's say, but we also have like web programmers, designers, and so on. So, well, if you want, I can make like a small presentation on what our project it's about, and I think that probably will be something interesting for the community because most of the people saw us on Twitter like Forsy Fools, not like iGEM Madrid UCM. So maybe that can lead to confusion, but it's because we think that the project is something important for our idea. So I will share screen. Hope that it works because Zoom is a bit confusing for me. Okay, I think now it's okay. Can you see the screen?
Yeah.
Okay, I will try to be very brief. Okay, here it is. Wow. Now I can see your faces. That's cool. Okay, so well, welcome. I will try to resume all the contents of 4C Foods project. And well, what actually means 4C? 4C are the acronym for cyanobacterial cyclic carbon capture. Basically, we want to create a technology for converting carbon to products of interest. So we will speak a bit about the problems that our society is facing right now, what is our technology, what we are different, what are our plans for the future, and what actually is the team working behind the 4C Foods project as an iGEM project. So first of all, well, all of us are familiar with climate change, with global warming, with emissions rising, and recently we have even discovered that the axis of rotation of the Earth has slightly shifted just because the ice melting in the poles and so on. So those are signals actually that something is going bad, and we would like to make something for giving a solution for that problem. That's a really big problem that has to be faced from very different perspective, and we want to be part of that solution. So actually we have some solutions for the future. For example, we have renewable energies, we have solar panels, wind turbines, a lot of different things. But of course, those solutions are mainly based for energy and are not for all sectors. For example, you can produce cheap electricity, but a plane, at least with the technology you have so far, could never fly with this electricity, or a truck, or even you cannot produce drugs or textiles with this electricity. So you need something else more. And that's actually a real problem that our society is facing, because all of these materials are still coming from some fossil fuels and fossil sources. So that's a big problem, but in this problem we see that a solution. We see an opportunity within this problem. And that's the basic idea for Seafoods project. We think that our society has an urgent need for a cleaner and circular bioeconomy, well, a circular economy in general, but we would like to focus in the bio part of that economy. And we think that there is a very big market that is uncovered by electrification. Our society is trying to become more sustainable, just shifting all the applications for electric input. But there are some applications, as we have mentioned before, that cannot be electrified. So we would like to cover the needs of those markets, let's say. And to cover that needs, we would like to inspire nature. So actually, what's the technology we are proposing to develop? Our technology is simple. Basically, is using photosynthetic organisms for converting carbon dioxide as a contaminant with the energy of the sun, and with using water to biofuels, chemicals, or other compounds that are relevant for our society. And to do that, we will use engineered cyanobacteria as the core of our project, because they are the most efficient photosynthetic organisms in the world, so maybe they have something to tell in this situation. And to do that, we will base all the technology and all the development in already proved concepts that are just waiting for combining all of them together and developing a solution for these problems. So, as we have mentioned, the current situation is not a circular economic model at all. It's a highly pollution, non-renewable model that is based on just extracting energy and feedstocks and converting them into products using a linear approach that, of course, pollutes a lot and accumulates a lot of greenhouse gases in the atmosphere and a lot of contaminants. So we would like to shift that situation. We would like to make a change, and the change will be that. We just want to close the cycle, introducing cyanobacteria on it, and this cyanobacteria will just convert the greenhouse emissions, especially the carbon dioxide, in again useful biofuels and products. This process will be near zero emissions, will be carbon neutral, and especially their energy inputs will not be electrical, will be directly the light from the sun. So it's something desirable for even bypassing all these kind of biorefinery platforms that are still depending on a lot of different steps and a lot of biomass processing. This will be like a direct conversion process. So actually our proposal is that, but what actually makes fossil fuels different from other photosynthetic chemical production technologies or even biomass harvesting technologies? Well, actually, most of the photosynthetic organisms industry is based on producing biomass. Biomass for animal feedstock, biomass for converting it to foods, biomass for fermentation, for vitamins, whatever you can imagine. But this process has a drawback, and those processes are kind of expensive because they have a lot of different steps, and each of those steps has a cost. So you have to grow the biomass, you have to harvest it, and they grow pretty dilute, so you have to harvest them using a lot of energy. After that, you have to extract the products of interest, you have to process those products, and in the end, after purifying those products, you have your final products. And of course, depending on the way you do these kind of operations, the process can be even more expensive than the product you are producing. So we would like to offer a solution for that, and the solution is simple. We just want to change the paradigm. We don't want to harvest biomass. We want to use biomass as a tool. We want to use this biomass as a catalyst. So our idea is developing photobiocatalytic processes. We would like to use a bacteria that is capable of taking everything that we don't want, all the carbon dioxide, all the minerals we give to them, and convert them directly to products of interest without producing biomass even. Of course, in these processes, depending on the way we title them, you can produce biomass, but it's not like the main product. Biomass is just like a byproduct that you would like to minimize in order to obtain your product of interest and the highest yield. And of course, that's the technology, but anything in our society needs to have an economical output. So if we conceive fossil fuels as a company, of course we are aware that this is an iGEM project, that the entrepreneurial part is important, but we are not going to change the world from one year to the next one. That's a slow process. But yes, we would like to give a brief insight on how can we become a company. So basically our goals are clear. We would like to develop novel overproduced robust cyanobacterial strains Those strains should be developed in a way that can be easily implemented in already existing industrial facilities. And also because the cyanobacteria is the core of the process, it's not the products you make, it's not the feedstock even. We would like to develop flexible solutions, depending on the climate of the regions, depending on the customer, depending on the needs of product you would like to create, you can develop different strategies. So that's the key points of Farsi-Foods technology. And to do that, we have developed like a small business model where basically we offer those microorganisms and also technological advice and counseling to the companies that are interested in implementing them. To do that, our key activities, of course, will be research and development. We would like to build a strong connection with university and with research centers because we think that that will be a win-win relationship for both of us. And also, of course, we think that it doesn't matter that you are doing science. The important thing also is not doing science, of course it is, but also that you communicate that science to the society. We would like to make society aware that this is important, that we need to make a change, and that if they support an initiative like ours, this change could be possible. So we think that communication is a key point in this. Of course, our clients will be industrial biotechnology companies, maybe investors, industrial owners, and so on. And our partners, of course, will be investors, that's clear, but also specialized engineering companies, especially in the ambit of bioprocesses, that will help us to develop these processes in collaboration with us or us collaborating with them, and also university and research institutions. That's like a helicopter view of our business and design that we could develop for Farsi-Foods. And speaking a bit about numbers, there are two important markets in this way. One of them is bio-based chemical building blocks that basically you can build almost out of carbon using this technology, and also biofuels. So biofuels market is maybe smaller, but we think that it's easier to make a proof of concept based on biofuels. So the project of 4C Technology is applying this cyanobacterial cyclic carbon capture to biofuel production. So basically those are the ideas of our project, but framing it on the iGEM competition, this is our roadmap. We are already here. We have almost searching the members of the team. We have developed our project ideas. We have made all the designs from a theoretical perspective. And now we are fighting a bit for getting all the materials, because at least in our region, it's kind of tricky to get enough funds to get some partnership, and we're still struggling with that. But luckily, in the beginning of June, we can enter the lab and we can start working on this project from June to mid-September, more or less. And from mid-September so on, well, it's the wiki freeze, it's all the content you have to develop for iGEM, and after that it's Jamboree, that luckily will be presential in Paris, and we are really excited for attending Jamboree and presenting all of our results. This is the team. As I have already mentioned, here there are 8 people, because recently a new member has added to the team and we didn't have yet a picture of that member, but will be soon here with all of us. And that's all, actually. Those are the sponsors we have on the right side. Those here are the sponsors that are giving us materials or money. On the left side are the partners that are helping us with the design, with the technological approach, and so on. And that's all. I hope that this idea has been interesting for you. And of course, we can provide more detail about different things. So please ask us everything you would like to ask. Thank you.
Thank you so much for that exquisite presentation and explaining more about your project and your team's aims. So could you tell us more about what your human practices for this project might look like, especially because climate change is such an important subject and is actively affecting our planet every day. So what does that portion of your project look like for your team?
Well, Alvaro, would you like to speak a bit about that, or you give me a word? Okay. It's because we are currently working on the human practice part, but the person responsible for that is not here present. Is called Blanca, and is the member of the team that is not on the slides. But briefly, we have like two different concepts of human practice, and we would like to blend them together. On the one hand, we know that our society is unsustainable and that we need a change, but we have discovered that our society actually is not so aware about what sustainability is. It's like, of course, you know that you have to avoid plastics, and that become like almost a dogma. It's like you have to avoid plastics, and you never buy plastic, you never use plastic. Instead, you start building, for example, paper bags. But after that, you discover that paper bags pollute even more than using plastics. So first of all, attending to just sustainability, we would like to make a very strong strategy and very strong human practice, just communicating and receiving feedback from the society and communicating again about what they think that sustainability is and how can we teach in a way what actually has been proved to be sustainable. That's one side of the human practice part. The other side is more related with the technologies, more related with ideas, and we are actually working on that. We are developing all the concepts, but briefly that will consist on making interviews with people from industry, with people from research labs, and we would like to ask them, well, you know that this technology are not developed yet, but do you feel excluded from these green chains? For example, if you are a company that, a plane company, let's say, if you're a company that has planes or that you have trucks, or you're a logistics company, you know that your fuels are not going to be sustainable because they cannot be sustainable yet. Do you feel excluded? You don't feel excluded? Would you like maybe a greener solution for using biofuels instead of these more pollutant fuels? So we would like to gather all the feedback from different perspectives, both from industry and also from truck drivers or plane drivers and so on. And we would like to implement all that feedback in a way that, okay, maybe our solution is producing butanol using cyanobacteria, but we have to look for a solution to convert this butanol in a jet fuel, for example, or we have to use this solution to convert this butanol in something different for the people within the industry. So basically, that's our human practice. Will consist in these two very distinct boxes that we will try to build later together, because of course, we would like to offer these interviews with industry, with companies to the society, and make the society aware that the industry and the companies are not this kind of evil things. They are actually trying to make a change, but of course the challenge is bigger than most of the people think. It's not just avoiding plastic and saving whales and polar bears and so on.
And also we want to try to implement the idea in the people that iGEM is a real thing, because in America or in Europe, in the rest of Europe, there is everybody knows what not everybody, but most universities know what iGEM is, and here is a very no one knows about it. So another thing we want to do is to teach people about this and this kind of pathways in the research field, and also we are planning to go to schools.
Actually, for all this first part of human practice, we have already developed a web page, but it's in Spanish because it's more local based and so on. But for the future, we would like to take that landing page that we have built in Spanish and we will put it in the wiki of iGEM Translate and so on, in order that the community can see what our human practice has been during this time.
And also we are working on third and fourth generation biofuels. Because here in Europe and also in Spain, we tend to use first generation biofuels like palm oil, that we all know that it's very harmful for the environment. So we are trying to make the local community aware of this problem and promote strategies like algae or cyanobacteria as biofuel providers.
Yeah.
Thank you for elaborating on your human practices and letting us know how you're trying to reach your community and give them more insight into synthetic biology and how your team is using synthetic biology to help the environment and the climate. Well, iGEM Madrid, thank you so much for meeting with me today. Is there anything else that your team would like the audience to know about your project?
Well, actually, I just think that we have forgot a thing that is pretty cool, and it's that Alvaro here designed like a game for schools. And maybe it's not human practice, but we thought that that's cool because it's a way to engage, especially young people with synthetic biology. So Alvaro, would you like to explain the people in general, the community, how that Lego works? Because I think at least all iGEMers would like to have a game like this in their homes.
Okay, yeah. At first, it was because our Moclo syntax was kind of complicated to understand for me, and I thought, okay, maybe I could make like a physical model to mess around with the pieces and try to understand how all these connectors, parts, and things work. And then we thought, okay, we are going to try to explain what Moclo and Golden Gate and this kind of stuff works to children. Maybe it's more useful for them than for us. So we are now planning on a presentation and a kind of gamification for the children to understand how Moklo works, and we are going to present them like different characters with different superpowers, so they can choose which superpowers they want for another character, and they will play around with the pieces and try to make their own superhero with different superpowers. And we are going to explain them, okay, this is kind of the thing we are going to do with our cyanobacteria. We are going to give it superpowers that, like the expression of butanol and this kind of stuff. So it's a pretty nice project, and we also want you to know about it. And maybe it will be available for everything, because I have designed it in 3D, so the models will be available for everyone who wants to try to print it. So it's really nice.
As a social media member, I want to say that we are being more visible right now on social media, and we have like a different like sections, and we have a day with, and this section we want to share like a day with our team members, what we do, we're studying or we are in the lab time. And two, we want, and we have another section that we have, did you know that? And is articles. The last one was about bananas also suffer from pandemics. That is very funny. And then the great competition, that is a competition between microorganisms, but we want to do like algae or another science group. And also we have Science for All, and here we talk with like important people in Spain, because we have that section in Spanish, and we talk about photography in science and a lot of more themes that are really interesting, and a podcast that we have in Spanish, but we're working on doing all of this in English too, because it's very important to spread the word. And just saying that stay tuned with our media, and that's all.
Yeah, that's it.
Awesome. Well, thank you for telling us more about your video game that is in development and your social media themed projects that are in progress, where we can learn more about things going on with microorganisms, pandemics with microorganisms, and how climate change is affecting all of this. Well, iGEM Madrid, thank you so much for meeting with me again today. We wish you the best of luck in the iGEM Jamboree for 2021 and in the GenScript sponsorship competition.